Hey everybody, welcome to our office hour tonight. So let's jump in. The request tonight was to do a lot of different like geometry and trigonometry problems. So that's what we're going to do. So let's take a look at number one. In this triangle ABC, AB and BC are the same. So I'm going to first just make a triangle and I'm going to call it ABC. A, B, and BC are both 6, and the measure of angle ABC is 120 degrees. And they want to know the area of this triangle. So what I want to do is we should know that the area of a triangle is 1/2 base times height. So this is the base, and this is the height. So here's where we get our right triangle. Even though I didn't draw it too well, these triangles are going to be congruent because they're both right triangles, and we know that these angles are the same. Because if this is 120, then each of these down here are going to be 30, so that they add up to 180. And therefore, if this is 30 and this is 90, this is 60, and they have the same hypotenuse, so they're going to be congruent. They're both 30, 60, 90s. So if this is 6, even though, again, I didn't draw it too well, the side opposite the 30 is actually the short leg. That's 3, and this is 3 root 3. All right, so again, let's make sure we know our 30, 60, 90s. That's always x, 2x for the hypotenuse, and x root 3 for the other leg. So that's how I knew if this were 6, then this is 3, and that's 3 root 3. And finally, when we find the area, well, 1/2 the base, that is 3 root 3, times the height, which is 3. So altogether, that gives me 9 root 3. All right, so there was no reason to find the full base because then I was just going to take half of it anyway. So in these scenarios, instead of like doing base times height times a half, just think of half the base, this 1/2 B part, as literally half the base. All right, let's move on to number two. Here we have one where a kind of a common mistake is made, and that is this. So I'll make the mistake at first and then I'll fix it. So the tan of BAE. So we have it's definitely a right triangle because it's a rectangle. Um, and if the tan is zero point 0.6, I can think of zero point 0.6 as 6 over 10, then that means the opposite would be 6 and the adjacent would be 10, because tangent is opposite over adjacent. And then if I go down here to angle EDC, the tan is 0.25. Well, 0.25 is 1/4. So therefore, the opposite would be 1 and the adjacent would be 4, right? So it seems okay. But the issue is this. These are just ratios, and there's many equivalent fractions that would be the same as those ratios. And if it's a rectangle, then this side length and this side length at the top have to be the same. And one's 4 and one's 10. So that doesn't work. But they're ratios, so I can just fix them pretty easily. I can say, all right, well, what number does both 4 and 10 go into? And that's 20. So in order for this to be 20, I must have doubled the ratio. So this would have to be 12. And in order for this to become 20, I'd have to multiply the ratio by 5. So this would become 5. Now I have the ratios that satisfy the tangent and make it a rectangle because the opposite sides are congruent now. Now I can do BE over EC. So instead of being 6 over 1, which would be a common wrong answer, it's really 12 over 5. Okay, let's move on to number 3. So number 3 has, I'll do it a long way and then show you a little bit of a shortcut. So let's say we don't know angle B. I'll call that X. So this upper triangle here, those angles have to add up to 180. So 70 plus 30 plus X is 180. This is 100. And then I subtract, so X is 80. All right. Now I go to the bigger triangle. So if I look at the bigger triangle, those three angles also have to add up to 180. Well, I know that's 80 plus A plus B. That has to equal 180. And if I get A plus B by itself, then A plus B is 100. And that's what they want, the value of A plus B. So it's not like it took me that long, but the answer is 100. Now, you can do it a little more quickly if you just realize that this angle that I called X is part of both triangles. So the other two angles in both triangles, they have to add up to the same thing because combined with X, they have to equal 180. And if X is the same in both, then those two angles must add up to the same thing. And since these add up to 100, then A plus B has to be 100. So there is a way to get this without really doing any work. But if you don't see that, then the way that I did it the first way will suffice. Okay, number 4. This one is, I think, very challenging. So the first thing I'm going to do is to try to save a little bit of time is I do need the hypotenuse, but instead of doing Pythagorean theorem, hopefully we see that it is just a 5, 12, 13 triangle. That is a common Pythagorean triple, but I'm just doubling it. So 5, 12, 13 becomes 10, 24, 26. So the hypotenuse is 26. Now the next thing is the radius of the circle. If I think of this as the radius, then that means that this right here, I have a little square where all four sides of the square are the radius, or at least equal or congruent to the radius of the circle. Um, because I know that this and this are r because they're radius, and then I know that they're right angles because these sides are tangent. So therefore, I just kind of make a square. And then what happens is any external point, so let's look at A. You can always draw two tangents going to the same circle, and those tangents are going to be congruent to each other. Well, if this whole side AB is 10, and this piece is R, this piece right here is 10 minus R, which means this piece over here is also 10 minus R because both from A to both points of tangency have to be congruent. And likewise over here, from C to this point of tangency, first of all, has to be 24 minus R, because the whole thing is 24, and this piece is R. And then this other one has to be 24 minus R as well, because from C to both points of tangency has to be congruent. Finally, if I look at this point, that segment, 10 minus R, plus this segment, 24 minus R, that has to equal the 26 for the whole hypotenuse that I did in the beginning. And then from there, it's pretty easy. 34 minus 2R is 26. 8 is 2R, and I eventually get the radius to be 4. So the equation, that's the easy part. The hard part is kind of figuring out that this length and this length, they are really what we're looking for, are, and working our way around and really using the definitions for tangent and what it means to have an external point, the two different tangents that can be drawn and knowing that they're the same. So I think that one's quite a doozy. All right, now to one that's a little easier, I think. So the first thing I look at is I see a right triangle, I see a 3, something, and 5. So right away I should know that it's 4. We don't want to waste any time on 3, 4, 5 triangles. And then I want to know the area of the semicircle. Well, the area of a circle is pi r squared. So I'm just going to take half of that to get the semicircle. So I get area equals 1/2 pi. Well, the radius, well, if this whole thing is 4, the side length of the triangle is 4. That's the diameter of the semicircle. So the radius is going to be 2. And if I just figure this out, 4 times a half is 2 pi. So the area of the semicircle is simply just 2 pi. Okay. Moving on to number 6. This one, I am not going to really worry about that it's a rectangular prism in the sense of I'm not going to worry that like the volume is length times width times height. This one, I'm going to use the idea of scale factors. And I use it when we have similar figures. So the way it works is this. I want to find, in this problem, I'm going to find the scale factor first. So the scale factor is what I would multiply each single dimension, whether it be length, width, height, radius, perimeter, anything that's measured in a single dimension unit. What does that get multiplied by to go from one similar figure to the other? In this case, it tells me that the edge length, which is a single dimension, of y is 3 times x. So to go from x to y, I'm multiplying each side length by 3. Now, what happens is they're giving me information about the volume. Well, the volume doesn't get multiplied by 3. The volume always gets multiplied by whatever the scale factor is cubed, because each of the 3 dimensions gets multiplied by 3, and 3 times 3 times 3 is 27. So since we're multiplying by 3 to go from x to y, it means the volume to go from x to y is getting multiplied by 27. Well, they're giving us y. So again, we have to realize that y is 3 times x. So everything in y is bigger than x. So if they give us the volume of y, then that means we want to divide by 27 to get the volume of x. Rectangular prism x. So just do 525 divided by 27, and we get 19.4 repeating. And what I could do 19.44. That would give me my 5 characters that we're supposed to do for to fill in the open-ended problems. Or you could put this in like a TI-84 and do math enter enter, or Desmos and change it to a fraction, and you'd get 175 over 9, which again would be 1, 2, 3 fraction bar 9. That would also be 5 characters. So either answer would be fine on the SAT. Okay, number 7. In the figure below, we have this equilateral triangle, the total length of the 3 semicircles. So if I go from here, that's 1, that's 2, that's 3. So the total length around is 12 pi. So that means if I divide that by 3, they're each 4 pi. So what 4 pi really represents is the circumference of the semicircle. Well, the circumference of a semicircle is just going, well, let's go over. So circumference of a circle is 2 pi r. So half of that is going to be just pi times r. So if I do pi times r, that'll give me halfway around the circle, or I guess around the circumference of the semicircle. So that means I have 4 pi is equal to pi r, so r is clearly 4. Well, now I want the perimeter of the triangle. Well, let's just look at one of these radii. So that's 4. Well, if I look, I'm going to look at all these. There ends up being 1, 2, 3, 4, 5, 6 radii that make up the equilateral triangle, and 6 times 4 is 24. You could get that a bunch of ways. You could say, okay, well, that means the diameter is 8. There's 3 diameters. Each diameter is a side of the triangle. Anyway, you're going to get 24 is the perimeter. Okay, number 8. Volume of a cylinder is equal to the volume of a cone. So let's just set up that equation. Volume of a cylinder is pi r squared h, but I want to put a little r sub 1 here because it's going to be a different r when I jump over to here. That's equal to the volume of a cone, which is 1/3 pi r squared h, but this is r sub 2 squared h. And I want the value of r2 over r1. So what I really want to do is I want to manipulate this equation to get r2 over r1 is equal to some number, and that number will just be our answer. So a couple things I can do to get this going is I can just divide pi out and divide h out, and I'm going to multiply each side by 3. So I'm going to get 3r1 squared is equal to r sub 2 squared. All right. So this 1/3, I don't want to deal with a fraction, so I just multiplied it to the other side. Now, if I want r2 over r1, I should divide each side by r1 squared. So I get 3 equals r2 squared over r1 squared. Well, I'm getting there because I want r2 over r1, not r2 over r1 squared. So if I square root everything, then I get root 3 is r2 over r1, and that's exactly what we're looking for. r2 over r1 is equal to root 3. So it's just setting up an equation based off of that sentence they give you, and then just manipulating it to get exactly the expression that they're looking for. Okay. All right. So number 9 is we've got a circle that passes through this point, and what is the equation of the circle? So we could use Desmos. If you were to use Desmos, first of all, we have to know what tangent to both the x and y axis means. So either way, what I'm about to draw, you should have this in your head because if you use Desmos, you got to know what you're looking for. Um, if it passes through the point -6, 3, that's in the second quadrant. So I'm going to need this thing to be in the second quadrant. So I'm going to draw it like that. So this is basically what the circle should look like. To be tangent to any line means it touches it at one point. So it's going to have to look like this. It's going to have to hit the x-axis at one point and the y-axis at one point. And another thing, this is why I would just do it this way. I didn't use Desmos for this problem, although you could look at all the answers, see which one looks like this, and see which one, if you need further, see which one goes through this point. But the reality is if it's tangent, and we know that based off all the answers, this value over here represents r squared in the standard form of a circle. So therefore, the radius is 3. So if the radius is 3, then I know the center. If I go left 3 and up 3, then the center is -3, 3. And the only answer that has that as a center is answer choice D. Because again, the formula or the standard form is x minus h squared plus y minus k squared equals r squared. If I replace h with -3, it's going to flip to a +3 because it'll be minus a negative. And then this will just be y minus 3. So we get the answer pretty quickly just by knowing it has to be in the second quadrant, it has to be tangent, and then it has to have this as a center. Again, you could do Desmos, that's fine, but you'd end up having to check all the answers if you're just kind of just throwing it into Desmos. And there's nothing wrong with that. I just like to go over this concept as well. Because me personally, I can get this without even having to open up Desmos and type it in. All right, moving on to number 10. So the graphs, this is another one where you could use Desmos, but I am not going to. If you were to use Desmos, then I'll kind of give you some tips along the way. But first of all, I'm imagining I got this y equals 19 going across. And which of the following could be B? And we know they intersect at exactly 1 point. So the concept here is this. If it hits it at 1 point, then it either looks like, and I don't know how big the circle is. I mean, I do. It has a radius of 7, which will matter. But Again, I don't know, I don't really care how big I'm drawing it. That's what I or it could be up here. All right, so these are the two ways that it could be tangent to this line and then shifted left to right as much as we want. So the reality is the A is going to shift to left or right. That doesn't really matter. What we're focused on is B. So what we need is B is the Y coordinate of the center. So the center could be here or here. And if the radius, if this is R squared, the radius is 7. So my two possibilities in general, before I even worry about like multiple choice, just in general, are going to be if I go 7 this way or 7 this way. Well, 7 this way is 12 less than 19. So that would mean the center will be 12. And 12 more than 9, or sorry, 7 more than 19 would be 26. Well, of those answers, D is there. That's again a way that and again, I'm explaining it. If I were doing it, I would be doing it much more quickly. Anybody who wants to use Desmos here, that's totally fine. What I would do if I were doing Desmos is just throw this in as is. It'll automatically set A to be 1. That'll be the automatic slider, the default slider. So just leave that alone and make B all four answer choices, and you will quickly see that only D26 is going to make it the line y equals 19 be tangent to that. So Desmos is totally fine. Just again, I like the concepts more, and then if you can use those and then use Desmos, that's great. Or if you want to just think about it and figure out the answer, that's great as well. It's really comes down like a personal preference, at least for some of these problems. For some of them, I would think that one is definitely better, but here it's really kind of up in the air, and at least my opinion, up to you. Okay, as we move on, the last two problems that we did here, I was very indifferent on whether you would use Desmos or not, and I actually chose not to use Desmos, but could have seen easily why people would choose to use Desmos. These last two problems, I am going to just use Desmos, and I'll explain why. So the non-Desmos way to do a problem like this is to use completing the square. Now, if you do it appropriately, you could figure out the answer pretty quickly. So I might as well go over that way as well. But let's just do the Desmos way. So let me jump into Desmos and just put it in as is. So the benefit of Desmos is you don't have to do any rearranging. You just have to think about the amount of time it takes you to type things, which I would imagine many of you are faster than me, which is why a lot of times I err on the side of just like not using Desmos because I'm like, oh, I can just solve it by hand quicker than I can like type these things in. But as I digress here. So what you want to do, if you're going to do circles in Desmos, locate the high point and the low point. It should just be right there. All right, I'll move this over. So once you click on the circle, it is going to give you the high point and low point as well as the intercepts. What I care about is the high point and low point because if I want the x coordinate of the center, it is going to be the x value that the high point and low point share, right? I mean, just imagine drawing a vertical line through here. It would have to be x equals 8, so the center would have to be at 8. And that's it. It just wants the x coordinate. That's why I chose to not use the other way and to just use Desmos. So I hop back here and I realized that all it was asking for was the x coordinate of the center. So knowing that I can get it just that easily is why I think Desmos is a solid way. Now, you could do it this way. If you divide, and again, mathematically, like the teacher in me doesn't like this way, but this is a good way for just SAT. I like to think of it as just zooming in on the problem, the part of the problem that you actually care about. So the part of the problem I actually care about is this. right? And if I remember, I'm picturing this in my head. I only care about this part. So divide the two out, right? Again, the teacher in me, and mathematically, yes, we have to divide everything by two, and we have to move the 16 to the other side, divide everything by two, complete the square on both, all that. But if I'm just solving an SAT problem, I'm zooming in on, I'm only focused on what would happen here. All right. I'm not mathematically ignoring all the other stuff. I know it's happening. I just don't really care about it. And then what's going to happen is I am going to add something to complete the square, but it has to end up being x minus 8 squared. That's the only way I'm going to get this minus 16. So knowing that that's how it's going to end up and not worrying about anything else, I can see that the x coordinate to the center is going to be 8. So there is a way to do it, but you can only, to me, get to that level if you really know the other way. All right. So again, mathematically, we would divide everything by two. I would move this to the other side. I would complete the square twice. I would get it to look like this, and. But if we're just doing an SAT problem, then you could just do this work, which might even be quicker than Desmos, to get that the center, the x coordinate is 8. And if we wanted the y coordinate, we would have just focused on this part of the problem. And if we wanted the radius, we would have just focused on what would have ended up over here after completing the square twice. So there are shortcuts for these, but I really just think the Desmos way is pretty simple. Okay, let's move on to the last problem of the night. This is another one that I am going to use Desmos. Now, the reason I'm using Desmos here is because if I want the diameter, it means I need the radius. So then I need to know the values that I'm adding to each side to complete the square to get what's over here, and that represents r squared. But the fact that I've already got a fraction, I'd have to take half of 1 and square it and half of 13 and square it. Not that I can't do that. Again, we're talking about making decisions to do things as quickly as possible. I would decide I'm not doing that. I'm just going to use Desmos. So let's hop back into Desmos and talk about how we would find the diameter. All right, so that was the last one. So now again, I'm going to type in as is. So that's the benefit of Desmos. I don't have to do any rearranging or anything. All right, so we've got this circle. Zoom out a little bit. So again, when you click anywhere on the circle, it's going to highlight the highest point and lowest point. So now, in the last problem, I focused on the x because it asked for the x coordinate. But now I'm going to focus on the y's. The diameter is going to be just the distance from the highest point to the lowest point. That's just subtracting them. That's just 2.5 minus negative 15.5, which is just 2.5 plus 15.5, which is really just 18. So the diameter is just 18. So again, instead of dealing with all the fractions and the completing the square, I find it easiest just to do that. So we end up, let me jump back into our problem, and we just get that the diameter is 18. And even if we didn't have fractions, we would still get r squared, have to find r, and then double it. I'm not saying any of that is like too difficult. I'm just saying it takes time, and I think that Desmos can quickly get that the answer is just 18. All right, that is it. So thank you for joining us. Remember, we have TikTok, YouTube. We offer one-on-one tutoring. We have 8-week SAT prep courses. So if you're looking for any more info, just follow up about any of that. And thank you for attending. And I will see you all next Monday. Have a good one.